Hi, I'm Grant Godding, and this is my Lab 1 report for the Charged Tape Lab. The purpose of the lab was to have an experiment and prepare a charged piece of tape, scotch tape, or clear tape, and observe the interactions between it and other objects, and to approximate how much excess charge was on the piece of tape. In the experiment, we created a charged tape like this by creating a U-tape and stripping it off from a base tape. And this caused electrons to be stripped away from the tape, making it negative. We then saw how it would interact with things such as a table, our hands, a negatively charged plastic pen cap, and then we also placed tape over two books like such in this drawing, and brought another piece of tape that we got charged and see how the two of those would interact with each other. So in this lab, after we did the experiment, first calculated the force of gravity on the tape, which is just mass times acceleration. The mass of the tape we found was 0.0002 grams, and the force multiplied by the force of gravity to get 0.00196 newtons. The distance of separation found between the two pieces of tape from the previous slide was 2 centimeters. And so we plugged it in, used this equation, where 1 over 4 pi epsilon naught is just 9 times 10 to the 9, and we set this equation equal to the force of gravity, and we found that the charge on, and we plugged in 0.02 for the distance here. We found that the charge on it was equal to 9.9 times 10 to the negative 9 coulombs. Next, we found the number of electrons by dividing by the charge of an electron, because in this equation here, we want to find the field, and the force is equal to the charge of an electron times the field. And we found that to be 5.83 times 10 to the 10. Next, we found the total number of atoms by calculating the area and dividing by the size of an atom, which was, we found the area to be 0.2 meters times 0.02 meters, and the size of an atom was 1 times 10 to the negative 10. And then we got the total number of atoms to be 4 times 10 to the 17. And then to find the number of electrons, the ratio between electrons and total atoms, you just divide the two, and we got 1.5 times 10 to the negative 7. Here's my code, plugging in all my values up here, and setting all the math. This white arrow is the force of the electrons, electric force from the tape down here. That's pushing it up, and this is the force. The blue arrow is the force of gravity that is pulling it down. And here again, found their charge. In conclusion, we're tasked with answering a couple questions. What if electrons had a positive charge, protons had a negative charge? Would it change anything about the observations we made? And the answer is there would not be any changes in the observation. It's just convention that things are positively or negatively charged. The opposite charges would still be attracted to one another, and an object with the same charge will still repel each other. Why is it important to handle the charged tapes as little as possible? It's because charges will diffuse or ground itself on something. So when you touch it, the electrons disperse and try to move to a naturally transfer to a more equal or stable state, so like a neutral state.